In this video, we're going to be working with one of the ways we can multiply vectors together. There are two types of products we can find with vectors, and the one that we're going to focus on in trig is a dot product. The other type of product is what's called a cross product, and we're not going to touch base on that at all this semester. Okay. When we find the dot product of two vectors, then we use the dot like we would if we were multiplying two numbers together. And the important thing to keep in mind when you're finding the dot product of two vectors is the dot product is always a scalar. Remember, scalar just means it's a number. It's no longer a vector. When we multiply two vectors together in this way, we just get a single numerical value. So maybe we will say that u is the vector u1, u2. Okay, v is our vector v1, v2, or its components. When we want to find the dot product of those two, okay, the way we do that is we multiply the first components, so u1 times v1, and then we add to it what we get when we multiply the second components, u2, v2. For any of you who saw matrix multiplication in your college algebra class, it's a whole lot like multiplying matrices together. So the first times the first plus the second times the second. If you get down the road into a class where you're looking at three-dimensional vectors, which all of you likely will in the paths that you're looking toward, it'd be the same thing with three components. First times the first plus second times the second plus the third times the third. So maybe my hands aren't communicating with my brain today. Maybe we have the vector 2, -3, and I want to find the dot product between 2, -3, and 1, 5. The dot product there would be 2 times 1 plus -3 times 5, or 2 minus 15, which is -13. So let's look at -4, -2, dot product of that with 5, 3. Okay, and whatever else I come up with here, maybe 3, 7 times the vector 0, 2. Go ahead and pause the video if you'd like and find those two dot products and then turn it back on and see if you're going down the right path. Okay, so on this first one, -4 times +5 is -20. -2 times +3 is -6. Adding them together gets -26. On the last one, 3 times 0 is 0, plus 7 times 2 is 14. 0 plus 14 is 14. Some properties that vectors have with their dot products. Okay, and these are all in your textbook, but I'm going to go ahead and write. I won't necessarily give examples of them, but I will write them down. But we have the commutative property of multiplication, I guess you could say, with dot products, because u dot v and v dot u are the same, because either we're taking u1 v1 or v1 u1, okay, plus u2 v2 or v2 u2. Okay, those sums are going to be the same. If you take the dot product of any vector with a 0 vector, meaning the x component and the y component are both zeros, then you're going to get 0. Because you're adding up a bunch of zeros. We can think of dot products as being distributed. If you want to take the dot product of u and the sum of v plus w, Then v plus w is another vector times this guy will give us a scalar. But we can take u dot v and add that to u dot w. Ooh, those are dots in between there. If we take the dot product of a vector with itself, okay, then let's say its component form was v1 and v2. We would have v1 squared plus v2 squared, which from our last lecture would be the square of the magnitude, kind of from the Pythagorean theorem. Also, if you want to take a scalar times a dot product, you could distribute that c into u first and then take the dot product with v. Or you could take the scalar times v and then take the dot product with u. Okay, and all of those, or you could take the dot product first and then multiply times c, but all of those would be the same. In the next video, we're going to do some more things with vectors, but I don't want this to be too long.